Okay, EdExcel P3, chapter review 6, looking at differentiation questions, doing number 7. So we have a max point of some sort of curve, of a maximum point, with the curve has the equation y equals x times root sine x. We have a restriction that x is between 0 and pi is the point A. So this is point A. Show that the x coordinate of point A satisfies the equation of 2 tan x plus x equals to 0. So we know that the dy dx at point A, the gradient at point A will be 0. So dy dx will be equal to 0 at point A. Okay, so that becomes our new question is, what is the x of this? And we can solve for that. And we make it look like tan x, 2 tan x plus x. So first step is to put this y in a form that is easier to work with. So let's take x times sine x to the power of a half. And we want, this is immediately a function times a function. So we're going to be using the product rule. Product rule states u dash v plus v dash u, where our u is going to be the first function. And we can pick either. And the v is the second function, which is sine x to the power of a half. U dash is the first derivative of x, which is 1. And v dash is the first derivative of that. So use the chain rule. It will be a half, bring down the half, times sine x, minus 1 from the original a half. So a half minus 1 is negative a half. And you times it by the first derivative of inside the bracket, which is sine x. First derivative is cos x. Okay. Product rule. So first we would do u dash v goes that way. And then we do v dash u goes that way. U dash v 1 times sine x to the power of a half. So dy dx is equal to u dash v, which is just sine x to the power of a half, and v dash u, which is this whole thing. So let's say it as a half times x times cos x, and then the bracket. Okay, sine x to negative a half. This is going to be equal to 0. So this is our dy dx, and we want that equal to 0. So to simplify these things, I try and take out a highest common factor of the negative power. Take out a highest common factor of the negative power. So this whole bracket. So if we take out a highest common factor of sine x to negative a half, it's not really more like a lowest. If you take out a common factor of it, of the negative power, it will hopefully sort it out. So let's see, what do we need to times this by? Well, we would have to times it. Let's take a look at what happens to it. So if we had sine x to the power of negative a half times by the same base times something, needs to equal sine x to the power of a half. So this is in order to find out what's going to be left over once we've taken out the common factor from this first term. So we want to know, what is this power going to be? Okay. So, well, if we look at it another way, it's sine x minus a half plus or minus something needs to equal sine x to the power of a half. And so if you look at this, we need to end up with a half. So what do we have to add? Well, in order to end up with a half, we add 1. Okay. So we're going to have sine x to the power of 1, which gets rid of that annoying negative thing, negative exponent. So we just have sine x left over there. And of course, the second term, the whole thing comes out. So we have a half cos x times by 1, just to make that. So that's all equal to 0. Okay. Nearly there. We want to make it look like 2 tan x plus x. We can divide through by 0 to get rid of that. So we have sine x plus a half cos x is equal to 0. So we just need to manipulate that a little bit. We know we want tan. So if we divide by both terms by cos, let's see, because we know that that will give us tan on the left here. So tan x plus a half. I feel like I lost an x somewhere along the way. Where is it? Here. Just to go and fish that out. So that's one of my errors. So that should have been there still all along. Okay, now we have another x over there. Good. Just following the correct the error. Okay, so we're nearly there. Got tan x plus a half x equal to 0. So we just want that to be times by 2, so that we have the times both sides by 2, times that by 2, times that by 2. So we ended up 2 tan x plus x, which was the requirement. Maximum point, show that the x coordinate of point A will satisfy this. So that is the x coordinates, and that will be the answer. Great.